Okay. All right. So next slide, please. So here's a brief overview of some of the things that we plan to talk about today. First, there will be a quick background and history of the Class 2 regulations, and then the impetus and goals for our regulatory review. Next, I'll provide a high-level description of a number of our proposed changes to the regulations, which will constitute the bulk of the presentation. And finally, we'll talk briefly about where we are in the regulatory review cycle and our desired outcomes. Again, I kindly ask you to keep your questions and comments to the Q&A session, which will follow the presentation. Now, we note that in the interest of time, we'll not be speaking about every proposed change, which is laid out in the discussion paper, but we'll be happy to speak to any of the proposed changes during the Q&A session, even if there wasn't a slide dedicated to it. Next slide, please. Move on to the next slide, please. Okay, so the CNSC has a robust regulatory framework that details the documents that outline the CNSC's approach to regulating the nuclear industry. Now, the framework combines all the existing documents and document projects in a clear and logical manner according to the regulated facilities and activities, safety and control areas, and other areas of regulatory interest. I just noticed that we're on the wrong slide here. I think we need to be on the slide number 3. Apologies for the, just go up to slide number 3. I'm talking on the wrong side. There you go. And we'll move on to the next slide in a short while here. So, and then CNSC's regulatory framework includes a structured, comprehensive suite of regulatory instruments that are used to achieve the CNSC's mandate. So now we're ready to move on to slide number 4. Okay, so we'll get to slide 4. So now the Nuclear Safety and Control Act establishes federal authority for the consistent regulatory oversight of all nuclear activities in Canada and assigns the CNSC powers to make regulations, issue licenses and certificates, and enforce compliance. In addition to establishing the commission, the Act establishes that the nuclear-related activities can only be conducted by persons or organizations that are licensed by the CNSC. A person or organization must apply to the CNSC to obtain a license, and applicants must demonstrate that they meet the requirements set out by the CNSC. And finally, once a license is obtained, CNSC has the authority to ensure that activities are conducted safely through processes of verifying, enforcing, and reporting compliance. We'll move on to slide number 5, please. Okay, so here's a list of regulations that make up the framework that fall under the Act. They're categorized into 3 groups. There are regulations of general applications, regulations by facilities and uses, and finally regulations about the conduct of the CNSC business, such as cost recovery and commission rules of procedures. Okay, I guess we're ready to move on to slide 6. Now, the consultation is a cornerstone of the Government of Canada's regulatory making process, playing a pivotal role in ensuring transparency, accountability, and legitimacy of regulations. In the context of the CNSC, this commitment to consultation aligns seamlessly with its priority of transparency in multiple ways. Firstly, inclusivity and diverse perspectives. Consultation allows for the inclusion of diverse perspectives, including those of industry experts, environmentalists, affected communities, and the general public. By gathering input from a wide array of stakeholders, the CNSC can make more informed decisions that reflect the concerns and the needs of various groups. Now, this inclusivity enhances the transparency of the regulatory process, ensuring that decisions are not made in isolation, but are rather based on a comprehensive understanding of the implications for all stakeholders. Second, building public trust. Now, transparency fosters trust between regulatory bodies like the CNSC and the public. When citizens are given the opportunity to participate in the decision-making process, understand the rationale behind regulations, and witness that their input is genuinely considered, it builds confidence in the regulatory system. Open and meaningful consultation processes are essential in demonstrating that the CNSC values public opinions, therefore reinforcing trust and credibility. Thirdly, informed decision-making. Consultation provides the CNSC with valuable insights, data, and perspectives that might not be otherwise accessible. Now, this information enriches the decision-making process, ensuring that regulations are based on the best available knowledge and expertise. Informed decisions, in turn, lead to more effective and targeted regulations, contributing to the overall safety and sustainability of nuclear activities in Canada. And fourth, anticipating challenges and addressing concerns. Through consultation, the CNSC can anticipate challenges and address potential issues before they escalate. Now, by engaging with stakeholders, the Commission can identify concerns early, allowing for proactive measures and adjustments to regulatory frameworks. Now, this proactive approach is key to preventing problems, enhancing safety protocols, and ensuring that long-term success of nuclear initiatives. So in summary, consultation is fundamental to CNSC's commitment to transparency. Now, by engaging in open, inclusive, and informed consultations, the CNSC can develop regulations that are not only robust and effective, but also trusted and respected by the public. Now, this aligns with the broader objective of ensuring the safe and responsible use of nuclear energy while upholding the highest standard of transparency and accountability within the regulatory framework. Okay, we're ready to move to the next slide, please. So in this slide, I'm going to take you through a detailed journey of how our regulatory proposals come to life in Canada. The process is very meticulous, involving multiple steps, careful consideration from various stakeholders. Firstly, the relevant organization initiates an analysis to craft regulatory proposals. Now, this groundwork is crucial and serves as a foundation for the entire process. Next, these organizations engage with stakeholders, seeking their valuable perspectives on potential policy approaches. And this engagement is pivotal in ensuring a broad spectrum of views are taken into account. Now, after these consultations, the regulatory proposals undergo thorough refinement, taking into consideration the comments received. Stakeholders are then invited once more to provide additional feedback, ensuring a comprehensive understanding of all aspects. The Department of Justice then steps in at this point, drafting regulations according to the specific instructions provided by the organizations involved, and these drafts undergo rigorous review. Now, the minister, in the case of ministerial regulations, or the Treasury Board for Governor and Council regulations, they meticulously review and approve the draft regulations for publication, and this can involve changes based on their expert evaluations. Now, once approved, the regulations find their way into the official Government of Canada newspaper, the Canada Gazette Part 1. Now, this publication is not just an announcement, it's also an opportunity for Canadians to engage. Public comments are welcomed, creating a consultative process. Now, these comments are carefully evaluated, leading to updates and finalizations of the draft regulations. Now, the minister or the Governor and Council, on the advice of Treasury Board as needed, then gives their approval. Finally, the completed regulations are published in the Canada Gazette Part 2. They come into force on the specific dates outlined within the regulations, marking the conclusions of this comprehensive and meticulous process. Now, this method ensures that regulations are not only well-informed and carefully considered, but also reflective of the diverse perspectives and expertise that shape our policy landscape. So that concludes the introductory. I will now hand it over to my colleague, Mike, to continue with the presentation.
All right, thanks very much, Peter. And good day, everyone. My name is Mike Hyman. I'm an inspector and senior program officer in the Accelerators and Class 2 Facilities Division. And I'm what you would call the technical lead on this project. So here's a quick overview of what I plan to talk to you about today. First will be a brief description of how we classify nuclear facilities in Canada, just in order to establish a bit of a baseline for this discussion. Next, I'll talk about how the use of accelerators has expanded over the last 20 years or so. I'll then get into the changes we're proposing to the regulations and finish up by showing you some of the interesting applications we've seen for accelerators recently, which will highlight our need to adopt the regulations. So first of all, just a quick backgrounder on how we classify various types of nuclear facilities in Canada. First, we have the Class 1 facilities, which are the big nuclear substance-based facilities like nuclear power plants, uranium mines and mills, and other such facilities. Next, we have what we call Class 1B facilities, which for the most part are comprised of high-energy particle accelerators, of which there are currently two in Canada. Triumph, a 500 MeV research cyclotron, and the Canadian Light Source, which is a synchrotron with a 250 MeV electron accelerator and a 2.9 GeV booster ring. Finally are the Class 2 facilities, which includes things like source-based irradiators used for things like food and equipment sterilization, brachytherapy afterloaders used for cancer treatments, and of course, accelerators with a beam energy less than 50 MeV. It is the regulations which govern these various types of Class 2 equipment which we are looking to adapt. Now, as you may or may not know, the regulations first came into force in 2000, or nearly a quarter of a century ago now. Since then, we've only made one substantial amendment back in 2010, which was to add requirements for the certification of radiation safety officers, or RSOs. That amendment did not include any changes to the parts of the regulations dealing with facility design or prescribed equipment safety, which means that when they were written, names like Mevitron, Theratron, and Selectron represented the pinnacle of technology for Class 2 equipment. I'm not particularly familiar with the regulations that were enforced prior to 2000, but I sometimes wonder if there was a regulatory requirement that everything needed to have Tron in the model name. Now, since the current Class 2 regulations came into force in 2000, the portfolio of radiological applications performed by accelerator-based equipment and facilities has expanded quite a bit. There are several reasons for this. First is a general shift towards accelerators and away from nuclear substances, most likely due to the extra security and safety concerns that go along with nuclear substances in general. Of course, when an accelerator is turned off, there is no radiation, which makes them difficult to use for creating something like a dirty bomb. It is also somewhat difficult to surreptitiously irradiate someone using an accelerator. It's not the type of thing you can just stick under someone's chair without them noticing. In the picture on the left, cargo is scanned at a border facility using an accelerator-based scanner, where 20 or even 10 years ago, these types of scanners typically incorporated a cobalt-60 radioactive source instead. Next, there is plain and simple innovation, where the basic human instinct to find better ways of doing things comes into play. Businesses are always trying to find ways of doing things more effectively and or efficiently in order to increase throughput or make a more desirable product with features that sets them apart from the rest. This is also true in the medical sector, where the ability to treat more patients in a given amount of time or treat them more effectively for better outcomes is always the goal. Medical accelerators, until recently, were mostly isocentric. That is, they rotated in a single plane around a fixed point in space in order to best treat cancer tumors. But now, some hospitals have started to operate equipment like this cyberknife here in the middle, which is essentially a medical accelerator mounted on the end of a robotic arm similar to those used in automobile factories. Our current regulations require that safety systems such as emergency stop buttons cannot be placed directly in a radiation beam, which is a bit of an issue given that these types of accelerators can literally point their beam anywhere in the room. Finally, we've seen an uptick in the use of accelerators outside of shielded facilities, what we refer to as mobile or portable accelerators, which I'll talk about in more detail later in my presentation. So in order to properly regulate all these new technologies and new uses of existing technologies, we saw that we would need to adapt our regulations in order to allow the industry to innovate while still ensuring safety. So in terms of the actual project we've got in the works, the first review of the regulations began back in 2019. But before we got going, we wanted to lay down some ground rules or goals that we would hope to achieve by amending the regulations. The first goal was to modernize the regulations in order to reflect the latest technological changes, and really, wherever possible, strive to create technology neutral regulations. We've also had a lot of time over the last 20 years or so to gain operational experience through licensing and inspections of these types of facilities. And we wanted to make sure that the lessons learned were used to inform our regulatory review. Next, and this is somewhat related to my first point, we wanted to make sure that the regulations allow for flexibility, but while still ensuring safety. This will probably manifest itself in the proposed regulations as a shift towards outcome based regulations and less focus on being prescriptive and unnecessarily detailed. Finally, we wanted to reduce regulatory burden wherever possible and just plain do everything we could to make the regulations easier to understand and use for all stakeholders, not just the licensed community. Sometimes, even as an inspector, I have trouble finding the specific section of the regulations that I'm looking for. Now, before I begin, it's important to remember that these are still all proposals, and as the old caveat goes, everything I'm about to say is subject to change. So, what are we proposing? First of all, as I mentioned earlier, we currently split oversight of our accelerators along a 50 MeV limit, where those that fall below that limit are regulated as Class 2, while the ones that are above 50 MeV are considered Class 1B. In case you're wondering, there is actually no scientific reason for this threshold. It was purely an administrative decision at the time the regulations were written. So, what we propose to do is regulate all particle accelerators as Class 2 facilities, regardless of beam energy. You might be wondering why this reclassification makes a difference. The simple fact is that at CNSC, if a facility is considered to be Class 1 or Class 1B, then it goes through a different licensing process when compared to Class 2 facilities. Before a Class 1 license is issued, there is usually considerable consultation with potentially affected individuals. There are sessions for interveners and formal reports prepared by licensing staff. The decision to issue the license is made by the commission, that is, a panel of several individuals. This process can take somewhere on the order of weeks to months. In contrast, the licensing process for Class 2 facilities tends to have fewer steps, and the decision to issue the license is made by an officer who has been designated by the commission to make such decisions. That is to say, the decision is made by an individual rather than a panel. As a result, the timeline to issue a Class 2 license tends to be more on the order of days to weeks. The original reasoning for this is that, in general, typical Class 1 facilities such as power plants or uranium mines and mills have a higher risk profile when compared to a typical Class 2 facility, such as a cancer center or a cargo screening facility. But when it comes to high energy particle accelerators, it could be argued that increased beam energy does not necessarily translate to a proportional increase in radiological risk. While a 500 MeV accelerator will likely still take longer to assess for a license when compared to a 15 MeV medical accelerator, and may still end up with a final decision being made by the Commission for a greenfield new license, the Class 2 process is expected to be shorter when compared to the Class 1B process, especially for minor license amendments once the license is issued. The next change we're proposing to adopt is a two-stream approach to licensing. So at the moment, our regulations are fairly prescriptive, and this actually works quite well for facilities that incorporate mass-produced equipment or for facilities where there's not a lot of variation from one to the next. A good example of this would be a cancer treatment facility, which essentially consists of a medical accelerator inside a shielded bunker. Even though there may be some differences in the floor plan from facility to facility, they all have very similar features and safety requirements. So for these types of facilities, regulations would specify that all Class 2 facilities must do, have, or include certain features, actually make them easier to license from the licensee side, because it is very clear exactly what we expect of them. It also makes it easier for the regulator, since a large part of the technical assessment can be done by ensuring that items from a list of requirements are present and functional. But while these prescriptive regulations are very effective for what we refer to as standard facilities, they don't necessarily lend themselves well for unusual or novel designs which do not fit the mold that was envisaged when the regulations were originally conceived. For these types of facilities, we would like to build some flexibility into the regulations while still ensuring safety. We're still in the early stages of deciding exactly how this will be done, but the general idea would be to allow licensees to define their own licensing basis to provide an equivalent level of safety where compared to the prescriptive regulations. So, rather than us telling them what they need in order to operate safely, licensed applicants would instead tell us how they propose to operate safely. Once their proposal has been evaluated against our outcome-based requirements, their proposal would be formalized by attaching it to their license, therefore making it binding. It is hoped that this change will allow for innovation and new ways of doing things while still ensuring safety. Excuse me for a moment. So I've already talked a bit about our plan to make the regulations less prescriptive and shift towards outcome-based regulations. If you're not familiar with the term outcome-based, probably the best way to explain it is through an example of a prescriptive requirement from our current regulations, and then show how we're intending to change it in order to make it outcome-based instead. Now, pretty much every nuclear facility in Canada is equipped with a safety system known as search buttons, or also known as person out switches. The idea is to make sure the room where the radiation emitting equipment is located is clear before turning on the beam. To do so, you go in, do a search of the area, and then push one or more buttons signifying that the area is clear. In the current regulation, we've been very prescriptive, saying that there needs to be a door and a device, and someone needs to activate the device, and then there also must be a preset time limit to exit the room and close the door. What we've learned over the years is that there are often many possible methods of achieving the desired outcome besides those which are currently specified in the regulations. So the question we ask ourselves is, what exactly are we trying to achieve here? And the answer to that question is essentially what we transformed into an outcome-based requirement. Irradiation must be prevented until someone enters the defined area where the Class 2 equipment is located and ensures that this area is clear of other people and the equipment is safe to operate. If we do decide we need to provide more details or guidance, this can be done in another document which would be separate from the regulations and much easier and quicker to update if necessary. We hope that doing things this way will allow the regulations to be more adaptable or even agnostic to new or changing technologies going forward. Next, I'm going to talk a little bit about regulation of mobile or portable Class 2 prescribed equipment. Creating specific regulations for these isn't really an example of us being technology neutral or adding agility to our regulations. Rather, their proliferation has made us realize that we do need to be agile with our regulations, because it seems that this is where a lot of the innovation is happening with respect to accelerators in Canada right now. This isn't too surprising given that the general shift away from nuclear substances over the last 20 years or so, especially in the industrial field. In short, when the current regulations were originally conceived, Class 2 equipment was typically operated only within shielded structures or facilities. Because of this, the current regs have no definitions or requirements specific to mobile or portable equipment. That's not to say that they are being operated willy-nilly without licenses or oversight from CNSC, because there are still many sections of the existing regulations which are applicable. Where we did find there were gaps, we created license conditions to fill them, and we've attached these conditions to every single license that is issued for a mobile or portable accelerator in order to incorporate an equivalent level of safety as that found in fixed facilities. The plan is simply to incorporate and formalize these existing license conditions into our regulations. The final change I'm going to talk about is a fairly simple one, but one which we hope will still make life a bit easier for our licensed community. In short, we are proposing to reorder and regroup our regulations so that they better reflect how they are actually used by stakeholders. In the graphic on my slide, I took a section of our existing regulations and color-coded them according to various regulatory themes, such as a requirement for management system, physical design, radiation protection, etc. As you can see, the colors on the left are all interspersed, meaning the themes are all kind of mixed up throughout this particular section of the regulations. What we would like instead is something more like the image on the right, where the regulations of a certain theme are grouped together. This will make it easier for potential licensees to find the information they're looking for and make it less likely that something will get missed. So that's most of my presentation done. But before I go, I did want to give you an idea of some of the interesting applications we've seen for accelerators recently. After all, this represents at least some of the impetus for changing our regulations in the first place. The first one I'd like to talk about is what is essentially a large scale CT scanner, which is most often used for characterizing lumber. Now, as you know, Canada has a lot of trees and therefore a fairly robust lumber industry. In order to avoid cutting down a bunch of trees which may end up being of poor quality or may have some sort of disease, a few representative trees can be cut down and scanned instead. I've got a basic schematic here on my slide that shows how it works. And here are some of the photos of it in action. On the top left, we can see the tree is clamped into a holder and raised into position on a turntable. The shielded doors are closed, and a scanner moves slowly up and down the tree while it rotates. When you do this, it generates an image something like this. The density setting on the CT scanner can be altered to show softer wood at the pith or harder wood closer to the edge. Now, some local university students even used this same setup for a research project to scan a jawbone from a minke whale. When they did this, they ended up discovering a new sensory organ in the process, something that would not have been possible without such a setup. And finally, probably one of the most innovative uses of an accelerator we've seen so far. Canada, like many other countries, has put a price on carbon based pollution and implemented a system where organizations who capture or sequester carbon can generate carbon credits. These can be used to offset emissions or can be sold to other organizations who are looking to become carbon neutral. The company that developed this piece of machinery realized that Canada's farmers' fields, of which there are many, are essentially carbon sequestration systems. In short, the plants in the fields capture carbon from the air through photosynthesis and store it in the plant or soil. This device, as it's pulled through a field in a partially shielded trailer, generates a beam of neutrons which are directed into the soil. A detector then measures and characterizes the carbon which is present. This allows for a quantifiable measurement of sequestered carbon, which farmers can turn into carbon credits to be traded or sold on Canada's greenhouse gas offset system. This creates a new income stream for farmers and a new source of carbon credits for companies hoping to become carbon neutral. So, regardless of the specifics that we end up with, and don't forget there are no specifics yet, we do have a vision of our desired outcome. We want a set of comprehensive regulations which will address multiple situations relating to Class 2 facilities and prescribed equipment. We want the regs to be modern and flexible, taking into account the fact that not all Class 2 prescribed equipment can be regulated using a single approach. And we want to provide simplification and clarification of the licensing and certification process while still providing an effective oversight, because in the end, that's why we're here. So that's about it for me. Thank you very much for your time. And at this point, we will turn to the Q&A to take any questions which you may have.
So before we do that, Mike, I think we have a few more polling questions we'll get to. Okay, so polling question number 2. So after the presentation, how would you now rate your understanding? I'll give you a few moments to answer that. Polling question number 2, or that is number 1 in post-presentation, that is. And if you're ready for the second one, I'll read the second question. Keeping in mind the presentation was developed with a broad audience in mind, did the presentation have the right level of detail for you to understand the material covered? So there are 2 questions here. Give you a few more seconds to answer. This is roughly about 45% who've already put in their responses. Okay, so I see that we have about 76 that participated. Wait a few more seconds. Okay, I think it's time to end the poll. All right, and share the results. So I've noticed that there was a bit of an improvement in terms of your overall understanding of the presentation. So I noticed there's more that have more of a excellent or good knowledge or understanding of the topic. And we still have about 13% that have a fair or poor understanding. So of course that's noted. And I noticed that so I'm pleased to see that that there was a right enough detail, right amount of detail, level of detail in the presentation at 82%. And so we're happy to see that. Unfortunately, we weren't able to get, but there was about 18% that didn't feel that there was enough detail. So that's duly noted as well. Oh, and then this question number 3, I missed was which of the proposed changes would you be most affected by? And so there's a short answer there. And I can't quite see the full question. Okay. I think you have to write in your answers. Okay, I think we're done with that. Let's move on to the Q&A session. We do have a few questions in the Q&A feature that have been written down. So I'll pass over to Mike to manage the intake of those questions. I did answer a few questions in writing. And again, questions that are within scope, we will try to address within the time that we have. And those that are outside of scope, we will follow up in writing and send the responses to everyone that have registered for this webinar. Over to you, Mike.
Okay, thanks, Peter. So I'm just going to go through the Q&A session, the Q&A questions. So the first question regarding applicability, would a hypothetical future proton or heavy ion facility for cancer therapy fall under Class 2, or would larger facilities stay as Class B? So this is the intent of our change to regulate all accelerators as Class 2. And the hope is that once these changes are made to the regulations, we will be able to regulate them as Class 2. Now, having said that, we currently don't have any proton or heavy ion facilities in Canada. So probably the first 1 or 2 are not going to be done before, or sorry, the first 1 or 2 might actually be done before these changes are made. So until these changes are made, everything will still stay as Class 1B. And even once we go, even after the changes are made, I have a funny feeling that the commission will probably want the first 1 or 2, at least to have a bit of a hearing with the commission, or possibly a panel of 1. So I am speculating a little bit here, but again, the expectation, the plan is that once the regulations come into effect, then we will be able to regulate them as Class 2. Okay, are logging CT scanners shown commonly over 1 MeV? Logging CT scanners. Oh, I'm guessing this is the example that I showed. Yes, I believe they are over 1 MeV sometimes. I'm honestly not 100% sure in terms of broadly across Canada, if that's the case. So I will move on to the next question. Could the WWHR be emailed out to all commenters? Oh, I think someone's asking if the presentation can be emailed to all people. I believe we do post these on our site. There's a couple slides. There are no feedback. Okay, so next one, I may pass this over to my colleague, Nick Bridges. I noticed in the first couple of slides, there were no input from broader public or Indigenous groups. Nick, are you able to handle that one?
Yeah, I am. Thanks, Mike. Hi, everyone. My name's Nick Bridges. I'm a senior project officer with the Indigenous and Stakeholder Relations Division at the CNSC. To answer that question for our anonymous attendee, um, we did do engagement on these changes with Indigenous nations and communities. We'd sent out the information in the summer and asked for input if there was interest. That being said, there wasn't a high amount of interest, but we did reach out directly to all of the First Nations, Métis communities. We don't work with any Inuit communities at the moment who work with the CNSC to all of our contacts. So they were aware of the changes. Hope that covers everything.
Thanks, Nick. The next one I may ask Peter. So will the proposed changes be released in draft form before approval publication?
So I think that refers to, sorry, let me just get there. So that does refer to the process that we went over in the first introductory of the presentation. So the proposed changes would be drafted and we publish it in Canada Gazette 1, where the public is given the opportunity to provide input and submit their comments through the formal consultative process. So that's Canada Gazette Part 1. And then we consider comments that are received. And that obviously is before the official publication of Canada that is in Canada Gazette Part 2. Okay.
All right. We have one from John Froats asking about interested in the thinking in the areas of configuration control, competency requirements, and reporting requirements. For configuration control, I'm assuming that means making changes to equipment or the facility once the license has been issued. I don't think we're going to be making any changes in that respect. Licensees should should always keep track of any changes that are made and ensure that making those changes will not affect the licensing basis. If it will, the licensing basis needs to be updated and the license needs to be amended. Competency requirements. We did make some proposals around the changes to RSO certification, and we got a lot of comments on that after publishing the discussion paper. And I will say that we have taken these comments into consideration, and we are currently, or actually I've just finished writing the What We Heard report. So that's out for peer review at the moment, and I'm hoping it can be published sometime late this spring or early in the summer. And that will talk a lot more about sort of what we heard and what we're planning to do going forward. I believe that's all we had for the Q&A.
Yeah, so Mike, I just wanted to add to the response I provided on the regulatory review process. The question that was asked about whether there would be an opportunity to comment on or review the draft regs. I just want to remind everyone that the draft regs have not been written yet. We're not at that stage. We're still in the pre-consultation stage, and we are going to publish a What We Heard report on our Let's Talk Nuclear Safety website, which will take into account that all comments received on the proposed changes that we've identified in the discussion paper. And that will be published, and everybody will have a chance to review that. When we do get to drafting, that's when we start working with the Department of Justice to put together the draft regulations and before publishing it in Canada Gazette Part 1, which you'll be giving another opportunity to comment on the regs. So I hope that provides a little more clarity.
Okay. And we have one more, whether CNSC has considered staffing and resource limitations on our side due to combining Class 1B and Class 2 facility licensing. That is still a little far out, but I would expect that if we are going to make these changes, we're going to make sure we have the expertise and the resources to actually carry them out. And again, the idea is to hopefully make the licensing process simpler. So instead of having these Class 1B accelerators, where you have to have hearings and go in front of the commission and have interveners. Instead, we can hopefully will no longer need all of that because we will have shown that the sort of radiological risk from these types of facilities is not much different from a current cancer center. How these regs apply to an organization developing it. So how would these regs apply to an organization developing a new type of class 2 device? So we do actually issue specific licenses for development and testing of class 2 prescribed equipment. So basically for companies or organizations or professors who are looking to design a new type of class 2 prescribed equipment, we do have that type of license available already. Right now, again, the limitation is the 50 MeV. So if someone right now is going to be proposing something like this that's above 50 MeV, then that will still be a class 1B. But again, the hope is that with class 2, we can make things a little bit simpler. Can proposed changes to RSO certification be discussed here from Jeff Doviak? I'd rather hold off on that until after the What We Heard report has been published, which should happen again in the next few months. We discussed it in there fairly rigorously because it was what we heard probably the most comments on, and we got some very good ideas in those comments. So we're gonna please wait for the What We Heard reports for that one. There's one here about funding for Indigenous organizations. I'll maybe pass that one over to Nick.
Again, yes. So for funding opportunities, this is something we'll just have to follow up with officially, but just for the audience's knowledge, the CNSC does have a newer, launched as of May last year, Indigenous and Stakeholder Capacity Fund that could potentially be used for more funding opportunities to provide reviews and comments. So we'll officially follow up with that one in writing now. Thanks.
Thank you. One more question. Since the nuclear substance regulations and class 2 regulations are so similar, is it in scope to combine the two or at least remove some portions to the NSRDR? Combining the two would be difficult because they sort of look after or regulate very different types of equipment and facilities. And so I don't think there's going to be much possibility of them being combined. However, we are ensuring that they are aligned. So there are some amendments being made to the or being proposed to the nuclear substance regulations as well. And I believe a discussion paper on that is either about to be released or has already been released. So keep an eye out on that. We are ensuring when we change these regulations that there are no conflicts between us and the other regulations. That's all part of the study that we do. With regards to logging, CT, will there be certification requirements for handling these equipments? We can have university projects that involve such equipment. So right now, our regulations do allow that if there are the possibility that these equipment will not be mass produced if it's only going to be produced sort of once and solely for scientific research. We already have an exemption for that. So if it's a one-time thing, then the equipment would not need to be certified under our current regulations. We are sort of planning to carry something like that forward, but we'll want to remove. So right now, our current regulations exempts equipment from certification only on the basis of it being used for scientific purposes. And we don't think that's quite right because you can still have mass-produced equipment being used for scientific purposes, and that should remain. If it's going to be mass-produced, they should be certified. So that's one of the changes we're looking to make. So again, if the equipment is a one-off, we probably will not require certification. But if it's something that is going to be produced or mass-produced and sold across Canada, then certification would be required. So I believe we're at the end of our Q&A, all the questions that were in the
Yeah.
Q&A.
Yeah, we can give some of the participants a little more time if they want to ask any more questions. I just want to remind those that are in this webinar that those that we cannot answer or that we haven't answered, either they're outside scope of our webinar, we will follow up in writing. So I see there's another question there, Mike.
Yes. Okay. So if the license is in place to make something safe, why do you still need to certify this? So this is a good question. Certification is actually more of a efficiency thing. So if a manufacturer is going to sell a piece of Class 2 equipment in Canada, there are certain things about that equipment that are always going to be the same. And that typically has to do with the equipment itself as opposed to the facility that it's used in. So since that's always the same, rather than us asking every single time someone wants to license a particular accelerator, say, what's the leakage of this accelerator, or how much radiation can come out through the jaws when they're closed. That's the same all the time, no matter where you install it. So it makes sense to certify that equipment because it allows us to sort of do part of the licensing up front, and it makes things quicker for licensees that want to operate it. So that's the reason why we do certification. And then we have a question, is there a way to give input as a stakeholder organization? Peter, can you please answer that one?
Yeah, I mean, irrespective of the entity, everybody has a right to submit their comments or concerns about the proposed changes to the regulations, whether you're a stakeholder organization, an individual, an Indigenous group. Throughout the process, anybody can submit comments on the proposed changes. They can follow up with more concerns or comments after this webinar and send us an email. Those comments would be considered. And you also have the opportunity to comment on the draft regs when they're published in the Canada Gazette Part 1. Hope that answered the question.
Okay, and then we have one more question. In the outcome-based regulations, why do you still need certification? So we may actually implement outcome-based regulations for certification. So we are thinking mainly on facilities where, as in the example that I gave, where we want to make sure the room is clear rather than saying you need to have a button or you need to have a pull cord and so on. So we could end up actually having similar requirements for certification, and they might be outcome-based as well rather than prescriptive. So we may still need, so why do we still need certification? That's something we actually looked at, and we think it still makes a lot of sense, again, mostly as a efficiency thing, because it allows licensees to get their licenses quicker, which again, in the Class 2 world, we deal a lot with medical, and we are always trying to do everything we can to get, basically do everything we can to not delay patient treatment in any way we can.
Okay. Okay, I think we're just about done. We're about 5 minutes to noon. So we'll end the Q&A session here. Appreciate all the questions that were submitted. And again, anything that was not answered, we will follow up in writing. I believe we have one more polling question before we move on. Okay. Okay, so how would you rate your level of satisfaction in the responses provided by the CNSC staff to the questions posed by participants in the Q&A portion of the session? Yes, we've got about 78 participants left near the end of the session, so, or that is 74. Okay, so aside of 2 that were not satisfied, we're sorry to hear about that. But generally, people are very satisfied with the responses to the questions. Okay. We can end that polling question. All right, let me just get this here. All right, so now that ends the webinar. So we'd like to thank everybody for participating. And I would like to remind you that there will be a survey that will automatically appear on your screen once you sign off from this from Zoom. And again, we appreciate if you can participate in the survey. It does help us in our engagement process. Again, we'd like to thank you for participating in our webinar. And we will follow up in writing for those questions that weren't answered. And any questions you do have relating to this project, feel free to send us an email. And we will remind you when the What We Heard report is published on our Let's Talk Nuclear Safety website. We anticipate near the end of fiscal year, which is March, or the beginning of fiscal year, sometime in April. Thank you once again, and have yourself a great day.